In this question number 3, we should know that threaded does not mean that it is threaded like a nut bolt or a screw. It is just going over the rod. That's what it means. Now you can pause the video, read the question, and then we'll discuss. Okay, so this is the rod and that's the ring on it. Okay, so the weight of the ring will be 0.8 times 10, which is 8 newtons. Okay, there is a force which is being applied, 7 newtons in this direction, and the angle is 45 degrees, right? So its horizontal component will be 7 cos 45 degrees. Similarly, there will be a vertical component of the same force which will be 7 sine 45 degrees. Okay, and additionally there will be a force upwards which will be the normal contact force of the ring on this rod. Okay, so what is the first part of the question? Show that the normal component of the same contact force is 3.05 newtons. So we'll get that by equating both up and down forces, and they have said that it is an equilibrium. They have mentioned it so many times, so let's do it. So 7 sine 45 degrees in vertical up, and the reaction force, normal contact force, will be equal to the downward force, which is 8 newtons, because we are in equilibrium. So R becomes 8 minus 7 sine 45 degrees, and surely it will be 3.05 newtons. Next, the ring is in limiting equilibrium. Limiting means if you apply even more than 7 Newton force, it will still be stopping, which means that the force which is in this direction will be the force which is in left direction. And in what is the force in left direction? Friction is the only one, right? And they're saying find the coefficient of friction, so we have to equate the two. So 7 cos 45 degrees will be same as force of friction. Force of friction is always coefficient of friction multiplied by normal contact force. So 7 cos 45 equal to coefficient of friction times, and we just got it, 3.05 Newton is the normal contact force. So mu will be 7 cos 45 divided by 3.05. That comes out to be 1.62, which is against our knowledge that the coefficient of friction is between 0 and 1. It is much more than 1. So it is so because it has not reached the point of motion yet. That's why it is giving us such a big value for coefficient of friction.